Good evening, friends. Welcome back to another session on logistics analytics. In today's session, we will be discussing on supervised learning technique. Okay. Which is decision tree classifiers. So in decision tree, we have two nodes. What are they? One is decision node as well as leaf node. Right, your decision nodes are usually used for any kind of decision making, like you have these multiple branches as well. Let me put it this way. This is your node, this is your decision node. Right, so this is decision node is also called as your root node, right? And each decision node will have these leaf nodes. This is your node, and then from your decision node you also have leaf node. This one, this is also one of the leaf nodes that you have. Same goes here. Right, so it is basically, you can say that it is mimicking the human decision in a way. Okay, and it is also talking about the graphical representation, and of course it is in a tree format, right? It resembles a tree, and to build a tree in decision tree learning, that is in decision tree, we use something called as classification and regression tree algorithm. Right, and when it comes to your decision tree, it is asking you questions, a simple one. Let me put it this way. Right, when it is asking you the question, right, based on your answer, it will again further splits into these nodes. Okay, you can call them as subtree. Right? And what are the different things that we looked at decision tree? We talked about root node, right? Root node is, by the name itself, you can say where the actual node started. That is where the actual decision tree has started. And then you also have leaf node, right? These are your outputs. Okay. And we also have something called as splitting. And splitting in decision tree terminology is dividing the decision tree into these sub nodes, right? And then of course we talked about subtrees. Yes. To begin with, you need to start off with the root node, right? And by using the column that is features, you'll have to look at the data set, right? Look for the, I would say, best feature, right? And then divide your root into subnode. That is root node into subnode. Okay. And then you start generating the decision tree. Let us look at one. So I will say this is the airport. And the arrival in this airport is between 10 a.m. and 5 p.m. So you say this is again your leaf node. You said yes. Right? You have your port somewhere to your inventory, and the distance. Let us also look at the distance. 50 miles, and the arrival and departure time are between 10 a.m. to 5 p.m. Now you're saying yes, you'll go with that. Why is that? Because it is 50 kilometers, I mean 50 miles away from your inventory, that is storage place, right? And then you'll have another node. This particular airport also has what we call as the maintenance of your, that is scheduling of your transit, right? Arrivals and departure. And again you say, yes, we will choose this airport. Right, you might also have a different airport here, which is 100 miles away from your inventory storage, right? The arrivals are, say, 12 a.m. through, say, 7 a.m. But there is no maintenance. All of that will come into picture when you take up a decision. But this is called the attribute selection measures. And when you start a decision tree, it is the first concept. So how do you get the information? Right? Information gain. So when you talk about information gain, it is the measure of change in entropy. Okay, and in a while we will be talking about an entropy, friend. Right? So what does entropy do? It calculates how much information a particular feature provides us about that class. Okay. So in decision tree algorithm, always try to focus on the information, that is value of information. So entropy is a measure, it is a measure for your given attribute, and it will measure the impurity. So how did you land up with this? How so if you're looking at this, the randomness talks about it. Right? And now let us look at the advantages of decision tree. And the first one is it will come in handy when you're dealing with decision related problems, right? Right? You can overcome the possible outputs on this. So these are few, I would say pros when it comes to decision. Now, of course, we cannot ignore that there could be few, drawbacks as well. So I would, point out at few. Okay. So in decision tree, what happens is you're going to have a lot of sub nodes and subtree. Okay. That will lead to your overfitting issue. Right? And when you have in decision tree, if you're having overfitting problem, that can be resolved using random forest algorithm, right? So in a decision tree, if we are looking at a decision tree, the types of decision tree are categorical, that is categorical variable decision tree, right? And then you have continuous variable decision tree, so in this, yes, if your variable, if your target variable is categorical, then it is said to be a categorical variable decision tree, and so is continuous variable decision, right? For example, whether the transit will happen, that is from this point to this point, as the track is taking your consignment, will this arrive on time or not? Right? So here in this, you also need to consider the fact that the type of the truck, the type of transit, right? Is it roadway or through air, or through a cargo ship, right? All of these you need to consider. These needs to be the significant variable. Clear, friends? And of course, we did talk about splitting, right? And leaf node is also called as terminal node. So decision tree talks about something called as sum of product. That is sum of product. Okay. Sum of product is also called as disjunctive normal form. Okay. So you are looking at this and you know that for each branch, right from the root node through the leaf node is having the same sum of product. Okay. And only when then you will consider that as a root node. And if your attributes keep changing, okay, you'll have to, yes, you have different attributes. Okay, and you need to come up with identifying each attribute, and this is said to be the root node. Let us look at the algorithm. Okay, let's try and understand on the algorithm. So yes, we were talking about entropy, right? So it is the mathematical entropy of one attribute is represented as E of S is equal to okay, this is entropy. And if you look at multiple attributes, multiple attributes, you have E of Then we also talk about reduction in variance. And reduction in variance is used for your continuous target variable. Okay. And the standard is variance is equal to sigma x minus x bar whole square divided by n, or let me write it here. Okay, I'm saying variance is equal to okay. And here the x bar is the mean of the value, right? And of course n is the number of values, right? So yes, for overfitting issues we discuss that to overcome overfitting issues we come up with a random forest algorithm, right? So this is one of the common problems to have, right? So there are two ways of dealing with overfitting. One is pruning, and other is of course random forest. Right? See, pruning is different from splitting. In pruning, what you do is you cut off the branch, right? So you start this is, let's say this is the root node. This is the leaf. And you start pruning from this leaf node, right? You do this, you cut off in such a way that you're not tampering the accuracy of your model. Okay. Another way is random forest. So here, so random forest is one of the techniques where you have multiple ML algorithms to come up with predictive model, that is predictive model. So here the sample data is coming up when you have a root node started already. Okay, it is considered from splitting the nodes, and this is called as bagging. So here, so if you look at regression models and decision tree, so we are saying that the independent variable and dependent variable is approximately nearing to linear, this linear model. And linear model will outperform in your decision tree based model. Right? How is that? So we also optimize the decision tree. So optimizing your decision tree classifier will let you look at the different attributes. Okay, the information gain, right? All of that. Now, let us do a hands-on practice. Let me launch let me launch the spider. So these are the library that I'm importing. I'm saying import pandas as PD. Let me run this. So here I'm importing the library pandas. The shortcut is PD. That is short for pandas, and as well as NumPy. Pandas is for your data visualization, and NumPy is for your numerical calculation. And I'm saying from sklearn.preprocessing import label encoder. Here I am defining a variable called central. Okay, I want to read this particular file. I want to read my data set, which is in Excel format. And here I am passing the path, that is location in which my data set is stored. So I simply copy this, copy the path and paste it in the parenthesis. Once I do that, since I'm using a Windows operating system, I will have to replace this backward slashes with forward slash. Right? Or I can also go ahead with double backward slash. Now I would like to read this particular file. Right? So my data frame has 105 rows and 4 columns. Okay, I would like to see if there are any null values. Okay. And then I want to drop if there are any null values. So if I say central dot column, see these are the columns that I have. I have order, arrival, status, distance. Now I would like to drop this particular column. Now, if you look at my data frame, I have only 3 columns. Okay, so I'm defining a variable called COLNAMES, and I'm saying list of central dot columns. I'm doing that after dropping the arrivals column. So here in predictors, so I'm saying column of the index colon 1. So here we have the target. Now I would like to split the data into training data as well as test data. If you can use Spider, Google Colab, Jupyter Notebook, PyCharm. These are the different IDEs that we have. No, it does not have to be Spider only. Okay. Yes. The reason I'm using Spider is, you know, I like it personally, and it also has few you know, these features which your Jupyter Notebook and Google Colab do not have, like your variable explorer, it identifies, it gives you alerts, right? And when you're dealing with multiple lines of code, there are few, you know, these features in this particular application. And then I would like to run this. I said train comma test. Okay, you split the data, train, and then you test. You're splitting, training, and testing. Okay, and then you're writing a variable, that is, you're defining a variable called model is equal to dt criterion is equal to entropy. This is your test data. This is the on time. Let us look at train data as well. So these are your order, that is, timestamp that you have. Okay, we are looking at the status. Okay. This is back order, right? Back order, on time. We have back order as well, late. Right? This is what we get in train data. Now let us try and predict the test data that we have. This. Okay. Let us test the, let us look at the accuracy. I would like to also check on the train data. the accuracy of your trained data. Just give me a minute. So here we are looking at train data and test data. The accuracy is what we are looking at. Yes, we know that there are, we'll check for null value here, and then if there are any null values, we'll drop them. Right, these are, and then we will optimize the routes. So here we are optimizing the routes. And then you split the data into train and test. See if you look for this. Right now, we are predicting the test data and train data as well. We'll start off with predicting the test data. What is that we have earlier? We were looking at the order data, arrival, and on time. The status. Now let us look at the accuracy of our test data. The same with train data as well. So you don't have to look at any you don't need to do any hyperparameter tuning here. So your test data accuracy is 96% and trained data accuracy is 94. Right? So that is how you deal with the decision tree. It is a supervised learning technique, and we also looked at the algorithm and how it works. All right, friends, we will stop our discussion here for the day and continue in our next session. Thank you all for joining. You all have a good day.